Okay, so I know it's been a bit, but I just wanted to come on here and do a question for Voltaic cells for maybe you are in summer school and taking this right now, or depending where you are in the world. So this is an old diploma question from Chemistry 30 from our released items. So here we have a cell, and it's a zinc carbon cell. There's some information. It looks a little bit different from some of the cells we've seen, and that's okay. We can figure out what's happening within the cell, but to just start off with, this question's pretty easy. It's asking what type of cell we have. Do we have voltaic or electrolytic? We know that based on the cell potential. If your cell potential is positive, it's a spontaneous reaction and you have a voltaic cell. If it was negative, it would have been electrolytic. So we can remove those distractors for C and D. And then we take a look about the paste. So you have a moist paste of aluminum chloride. So that's just like a fancier way of saying we have a salt, and we know that salts move ions. So that would be B, because electrons only flow with that wire going from the anode to the cathode. So we do know what we have going on within. So the answer for this first part is B. And then this second part, asking about what the cathode is going to be in the zinc carbon cell. So this part, I do think it's helpful to just take a look. I'm just gonna flip this way for a second at the data booklet. And we know zinc is reacting. And when you take a look at zinc, zinc is a Ra. Reducing agents undergo oxidation, and that happens at the anode. So I'm not looking at the other reaction, the one you're seeing over here, because that one is not in our data booklet. But I can tell from zinc that because that reaction was flipped, that was the reducing agent undergoing oxidation, that's at the anode. So that means your carbon rod has to be the cathode. So here we can rule out A and B because it is asking about the cathode. And we know that electrons, no matter what type of cell we have, always flow from the anode to the cathode. So this one, our answer is C. And then the last part of this question is to calculate the cell potential of the half reaction. So we can do this because in the original information, we were given the cell potential of the total cell. So if we go to solve this question, we know that cell potential, the formula is for the total cell, the cell potential at the cathode minus the cell potential at the anode. So we know that the overall cell is 1.50. We don't know what the reaction cell potential is at the cathode. That's what we're finding. And we do know the cell potential at the anode because that's zinc's half reaction. So negative 0.76. So now you're just solving for the cathode. So if you do need help with this, we are just going to remember that a negative times a negative is a positive. So we can drop the brackets and change the sign. And then you can move the 0.76 to the opposite side by subtracting it. So we'll get here that your cell potential is 0.74. So at your cathode for that half reaction, your answer would be 0.74. And then when you do put that into your numerical response, zeros will get a box, decimals get a box, and then you'll put in 74. So as always, I hope you found this helpful. If you did, please subscribe. If you have any other video you would like me to try, please just leave me a comment. And thank you very much for watching.